Hello, fellow RC scale builders. Um, I need to get back into my Zeroli Corsair. I've been out of it for a while. It's finally cooled down here in Florida, so maybe I can do some building. Anyway, I had this in the works a few months ago, and I finally decided I'm going to finish it. And as you can see, well, maybe you can't see because it's pretty busy with all these wires and stuff running around all over the place. But what's going on here is that I took two pneumatic retracts and I converted them to electric. And the two motors right here that you see, and this is really busy. But the two motors, you can see there's a shaft, a couple of shafts, a drive shaft. The two motors will be in the center section, and via the drive shaft they will drive a gearbox that I put in the retract. There's just simply no way of fitting anything in this space. If I wanted to go with a micro motor like Robart did, then I could probably do it, but the whole idea to this is that I didn't want to go that route. I don't particularly care for what he did. I'm not being overly critical of it, but I've seen him at the field and it's just not for me. So anyway, I got this thing working. If you've seen my previous video on my Spitfire retracts, this is the same controller. Uses a microcontroller and a motor driver. And this is, however, a whole different setup. This one doesn't use an encoder on the back of the motor. It just uses a standard motor, even though these are encoded motors. I went a different route this time, and I used a pair of Hall effect sensors on the gearbox to tell me up and down, and from there I digitally trim the retract in terms of movement. So in other words, when the down Hall effect gives me a signal, the microcontroller reads it and says, hey, you're close to where you should be locked down. I then have a routine that goes into what I call a digital trim. It is a digital trim. And it moves it a little further past that Hall effect sensor. The way this gearbox works in the Hall sensors is that these two pieces slide up and down on the housing so that I can adjust the Hall effects, but you really can't get a fine adjustment out of them. It takes a while. So anyway, it's a lot easier just to digitally trim them. Use them as an indicator that the gear is approaching where it's supposed to be, and then when it triggers, digitally trim it from that point on out. So already I'm getting too wordy, but let's give it a try. It does work. So I'm using two indicators here right now. They won't be in the final design, but I'm using it for engineering purposes to tell me the status of the gear. These are actually the Hall sensors giving me that signal. And here we go up. I'll try to give you some perspective here. And down. And the controller, if you've seen my Spitfire video, the controller actually has it actually has four different modes. It has this, which is a standard mode where both wheels go up at the same time. It has another mode where port leads starboard, and another mode where starboard leads port, for a staggered kind of retract. And it also has a random mode where it will just randomly select. So I'll just show you one mode. I don't know what this is anymore. Here's a dip switch. You can see it in there, right here. Get the wires out of the view here. There's a dip switch right there. See it? Right now it's off. It's in the standard mode, standard retract mode. I'm going to switch one of these switches, and it should either be starboard leads port or port leads starboard. I don't remember anymore, but let's see how it goes here. So it's the port led starboard. This is the port side, by the way. This is the nose of the airplane. Right here is the nose of the airplane. I'll just make a comment right now. There's not much of a stagger between the two because, well, this is the second controller I'm testing. This whole thing was integrated on a different controller. And I have a pot here, potentiometer, that controls the stagger. And right now I don't have there's a special tool to get in that and turn it. And I don't have the tool. But the stagger right now on this unit is it's not providing a lot of delay between the two. Okay, but hey, you get the gist of it. It definitely does work. So I'm going to put it back. Well, maybe I'll go into the range. No, you can't see much of a stagger, so I'll just put it back into the normal mode. I also on this unit have a fail-safe or an alarm that goes off so that when I'm at the field and say the gear is down and locked like it is right now, but the airplane is off, I'll shut it off. Just hit my phone the wrong way, so I'll have to splice this in. But I was saying, if I'm at the field and I accidentally power up my transmitter and turn this thing on, ordinarily what would happen is the gear would try to retract. Right now, you can hear there's an alarm. As I said, ordinarily, if this would happen, the gear would try to retract. And one of two things is going to happen with electric gear. If it's on grass, they might actually move and the airplane will collapse onto the grass. If they're on concrete or blacktop, they might not move at all. And what's going to happen is that the gear will stall, and you're either going to blow a fuse. I have a fuse down here, and that's probably what's going to happen. It'll blow the fuse, or it'll stall the motor and burn the motor up. So we can't have that happening. So once the alarm goes off, I know that the switch on transmitter is in the wrong position. It's in retract right now. It should be in the other position. All I need to do is put it in the position it's supposed to be in, and now the system is armed to operate. Other than that, the gear wouldn't move. It cannot move. Okay, and I see I got a set screw loose there. But you get the gist of it, and you act the way. I'm sorry about moving the camera around, by the way. I can't find my tripod, but hey, this works.